Hi, welcome to Mrs. Park's Algebra 1 class. This is Chapter 8, Section 2, using the distributive property. Alright, so when do we use this? The cost of rent for Ms. Cole's store is determined by the square footage of space. The area of the store can be modeled by the equation A equals 1.6 W squared plus 6W, where W is the width of the store in feet. We can use factoring in the zero product property to find possible dimensions of the store. Okay. Use the distributive property to factor. So in Chapter 7, the distributive property was used to multiply a monomial by a polynomial. As you can see here, we've done this in Chapter 7, where you just multiply the 5z with 4z plus, and then you multiply by 7. You can work backwards to express a polynomial as a product of a monomial factor and a polynomial factor. So in this chapter, we're going to use the distributive property, but it's really using it backwards. So instead of going this way, we're going to start here and factor out the 5z so that we can have it in parentheses. So here you have 1.6w squared plus 6w. And you can see here they both have w in common. So I'm going to factor out the w, and what's left here is 1.6w, and then you have the positive 6. So if you have this, its factored form is here. Okay. Factoring a polynomial involves finding the completely factored form. So whatever they have in common must all come out. Alright, here's example 1 using the distributive property. Again, when we're talking about distributive property in this chapter, we're talking about it in the sense that we are factoring it out. So we're kind of going backwards with the distributive property here. Alright, so you need to find a GCF. Excuse me. 27y squared plus 18y. Alright, we know for a fact that they both have y in common. Okay. When we factor out 27 is 3 times 3 times 3. 18 is 2 times 3 times 3. Okay, so you have here a 3 in common, another 3 in common, and 1y in common. So their GCF is 9y. Okay, 3 times 3 is 9. So you have 9y. So you're going to factor out 9y. So that means take out 9y from here. What do you have left? 3y. Because 9y times 3y is 27y squared. Okay. If you factor out 9y here, then you have your 9y times 2. So your 9y, that's what comes out. That's what's been factored. Okay, and what's left goes back inside the parentheses. The 3y plus, because it's positive, the 2. Okay. Now let's go ahead and try example B. Okay. You have here, you have 3 different terms. So we're going to factor all the 3 terms separately. So negative 4a squared b. Negative, you have that negative 1, times 2 times 2. A is twice, and b. Okay, negative 8 is negative 1, times 2 times 2 times 2. You have 1a here, and then b is squared. 2ab is already factored, so 2 times a times b. Alright, so they have here 1, 2, or a set of 2, and then they have a, and then they have a b. So all they have in common is 2ab. So when you factor out 2ab, so take out 2ab from here, and you're left with negative 2a. Factor out 2ab from here, and you're left with 4b. Factor out 2ab. It's already 2ab, so you can just put a 1 there. So you take out the 2ab, everything else goes in the parentheses. So negative 2a, and that's minus 4b plus 1. And that would be your final answer. Okay, so here is your turn, numbers 1a and 1b. So go ahead and try those two. Factor out each term completely. Find the greatest common factor. Take that out, and everything else goes inside the parentheses. All right, welcome back. So here we're going to move on to factoring by grouping. Okay. Using the distributive property to factor polynomials with 4 or more terms is called factoring by grouping, because terms are put into groups and then factored. the distributive property is then applied to a common binomial factor. Okay. A polynomial can be factored by grouping only if all of the following conditions exist. There are 4 or more terms. Terms have common factors that can be grouped together. There are 2 common factors that are identical or additive inverse is of each other. Okay, so the symbols here. You have ax plus bx plus ay plus by. So those go in parentheses. You can see they have the a and the x in common, so they factored out the x. Okay. Here they factored out the y. Okay. Now you see here they still have a plus b in common, so you're going to factor that again. So you have x plus y, and then your a plus b. And that parentheses means they are multiplied. Alright, so here is an example. So you're going to find terms that have factors. So these two and these two. They both have 4r in common. So they took out the 4r, they factor out the 4r, and what you have left, you have a q plus 2. Okay. Here they have 3 in common, so factor out the 3 and you have q plus 2. Now you can see the q plus 2 is also can be factored. So now you have 4r plus 3 times q plus 2. Okay, and that's your completely factored. Okay. Okay, so here's your turn, 2a and 2b. Find what they have in common, okay, and then factor them. And come back when you're done. Actually, now that I'm looking at this, I'm sorry. Now that I'm looking at 2a, okay. So they might not always be in order. So you automatically want to do these 2 factors, but then r and 5 don't have anything in common. So I would actually do rn. I would switch these two, because I think what they have here is r in common and 5 in common. So factor these 2 first, and then have your final product. Okay? Alright, so finish that and 2b, and then come back when you're done. So here's example 3, factor by grouping with additive inverses. So we're still grouping by factoring by grouping. So here you have 2m in common for these two. They took out the 2m. You have k minus 6 left here. And here you have 7 in common. So if you factor out the 7, you have your 6 minus k. Okay. And here, they look similar but not quite. So what do you need to do? You want it to be k minus 6. Right now, it's a negative k plus 6. So what they did was they did negative 1 times this and made that into a negative. So you have negative, and you have now k minus 6, because k minus 6 is the same thing as if you multiply negative 1, k minus 6. So we did the associative property. Now you can group these two, and now you have 2n minus 7, and you have k minus 6. Okay, so here's your turn numbers 3a and 3b. Go ahead and do those 2 problems. If you need to use the additive inverse, you can do that. Okay. All right, solve equations by factoring. Some equations can be solved by factoring. Consider the following. So if you have 0 multiplied by 3, it's 0. Okay. Also, if you have 0 multiplied by something that equals 0, it's also 0. If you have a negative number times 0, it's also 0. So basically, any number times 0 is going to equal 0. So notice that in each case, at least one of the factors is 0. These examples are demonstrations of the zero product property. So, zero product property. If the product of 2 numbers or 2 factors is 0, then at least one of the factors must be 0. For any real numbers a and b, if a times b is 0, then a may be 0 and b may be 0. Or both a and b both may be equal to 0. So in other words, 0 times 0 equals 0. You can also have 2 times 0 equals 0. Or it can also be 0 times 2 equals 0. So in other words, any number times 0 is 0, also 0 times 0 is equals 0. So it can be any one of those. Here's example 4. Alright, so when do we use this? If you have an equation like this and it says it equals 0, then there's two possibilities. You can say this part is 0 or that part is 0. Either or will make that equation equal 0. So if you have the first part, 2d plus 6 equals 0, you solve for d. Or, excuse me, or you can have the other part, 3d minus 15 equals 0, solve for d. So there's two possible solutions here. It could be negative 3 and 5. Okay, if you could check your answer, you can see that they're both correct. So for these kind of problems, you can say the answer is negative 3 and 5. Okay? So watch out for unknown value. It may be tempting to solve an equation by dividing each side by the variable. However, the variable has an unknown value, so you may be dividing by 0, which is undefined. Okay. Oops. Okay. So let's try another one. If you move everything, if it doesn't already say equals 0, you can make it look so that it looks like equals 0. So if you subtract 3c from each side, you have now c squared minus 3z equals 0. That means if I can somehow factor this, then one of them will be 0. So if I factor the c, you have c minus 3. That means c can be 0, or c minus 3 can be 0, in which case c is 3. So your answer is 0 and 3. Okay, here's your turn for A, B, and C. Go ahead and solve for your variable. So remember, there's either or. So you need to solve for 3n equals 0 or n plus 2 equals 0 and get two answers. You can factor it and make it look like two terms products equal 0. If it's not already equal 0, you can move that and say x squared plus 10x equals 0 and solve. Okay. Here is a real world example of when you would actually use this. Alright. Penny is a laboratory retriever who competes with her trainer in the agility course. Within the course, Penny must leap over a hurdle. Penny's jump can be modeled by the equation h equals negative 16t squared plus 20t, where h is the height of the leap in inches at t seconds. Find the values of t when h is 0. So this equals 0 is our equation. You're going to factor 4t. Now you have two products. So you have 4t times this will equal 0. It can be 4t can be 0, or negative 4t plus 5 can be 0. Okay, so you have your two answers there. So height is 0 inches at 0 seconds and 1.25 seconds into the jump. Alright, this is our last slideshow, so go ahead to your turn number 5 about kangaroos. So here, without even reading it, I know you're going to have this equals 0 and factor so that you have two answers for each. Okay, so go ahead and do that and make sure you put that away for your homework tomorrow. And thanks for watching.